Okay, so this is a video working through problems number 20 and 22 from the 11.5 homework. And on 20, they're asking us to find the missing dimension of the prism, which is the height of the prism, so that's x right there, and then round to the nearest hundredth. So they're giving us the volume, they're giving us a side length on this hexagonal base or hexagon base. I'm just going to draw a standalone picture of that hexagon. There's our 2, 2, 2, 2, 2, and 2. And the volume equation, always the same. Area of the base times height, always, no matter what the shape, area of the base times the height. Sometimes that area of the base is easier to get, but that's the equation. Our height is our x, our volume is 72.66, and that's equal to the area of the base times x. So whatever the area of the base is, to solve for the missing side length, or missing height, what we're going to do is divide both sides by that number. On the right, that's going to cancel out the areas. On the left, that's going to leave us x equals. I'm sorry, on the left, that's going to equal 72.66 divided by base. On the right, x equals. And so whatever that number is, 72.66 divided by the area of the base is our answer. So what I'm after then is the area of that base. So to get it, let's see, I'm going to grab a different color here. To get the area of that base, because it's going to come from this picture. This is regular, which means it can be inscribed in a circle. And it's tough to freehand a circle, but it's not terrible. Which means all these vertices lie on the edge of a circle. It also means there's a center to that circle. And from that center, we draw a line directly to any side. I'm just going to pick the bottom one at 90 degrees. That creates this length called an apothem. And the area equation that we looked at for regulars was half times the apothem times the perimeter. In this case, the perimeter, it's 6 sides of length 2. So 6 times 2, that's 12. So that's our P, or our perimeter. Or you could do 2 plus itself for a total of 6 of them, and that would get you the 12 as well. And then what we're after is the apothem, that length. There are several equations you can use to memorize how to get the apothem, but I just think about it in terms of what is it, and what shape are we looking at. So I'm going to grab a green pen. What we're going to do is split this thing into 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 6 triangles that are exactly the same. That's taking 360 degrees of rotation or of circle and splitting it up 6 ways. 360 divided by 6 is 60. That means each of those central angles, each of those top angles in the triangle is 60 degrees. Well, okay, so let's just draw one of those. That means this angle is 60. If I then split it in 2 with that apothem line, that's what this is. I'm then creating a thinner triangle, or if I just look at one of those 2 pieces, so there's 1, 2. If I look at just one of them, I'm going to get a 30 up here. 90, there's my apothem length, there's my 60, and the whole base on this thing is 2, which means half of the base is 1. So if I'm after the apothem, and I've got a 60 and a 1, I can say tangent of 60 equals TOA. So opposite over adjacent, multiply both sides by 1. 1 times the tangent of 60, still just tangent of 60, is the apothem. So whatever tangent of 60 is, that's going to be the apothem length. Now, if you know special right triangles, you can get this without needing to go to that length. You can just use the special right relationship, and you know you're multiplying by the square root of 3. But if you don't, you just use a trig relationship. So again, that's our apothem length. 1, but 1 times anything is just that thing. So that's A is tangent of 60. I'm just going to let the calculator do it. So half times tan 60 times 12. So let's clear this out. Half times tan of 60 times 12. Or 0.5 times tan of 60 times 12. That's 10.39. And I'm just going to let the calculator hang on to that number. Let's actually just call it 10.4. So my area of the base is 10.4. And again, what I'm going to do is I'm going to take that one is getting piped back into this equation. I'm going to take 72.66 and divide it by that. So 72.66, put that here, and then I'm going to let the calculator do the work. So divided by, and I'm going to hit second and this little minus sign. And every calculator has that little ANS, that answer. What that means is it's going to grab the number that it sees right here. It's going to put it in. So you don't have to worry about decimals. rounding, whatever, you just put it in there. And then the answer is 6.99 if we take it to 2 decimal places. So 6.99, and we're talking inches, is our height. And that's it. It's a lot of work in breaking down the shape just to get that apothem. And the actual volume piece isn't the challenging one. So that gets us our missing dimension on the prism. That's a hexagon. And then we're looking at the missing dimension on this prism, which has got a circular base. And when a prism has a circular base, we call it a cylinder, but the equation's the same, BH. And they gave us the H, that's 15, they gave us the volume. So I'm going to fill those two pieces in. So I meant to put a 15 there, didn't I? Let's grab an eraser here. Let's go back. I guess I'm using green. So I know the volume here. That's this one. I know the height here. That's this one. And then I don't know the area of the base, but the area of the base, it's a circle. The area of a circle is pi r squared. And unfortunately, they're using the letter z, which looks like a 2. You can call it an r if you want, because it's a radius. But I'll use their letter. So pi times z squared. And I don't know what the radius is. That's what they're asking us to get. So now there's my area of the base, pi times z squared. So now I'm going to let the calculator do the work from here on out. I'm going to divide, I'll switch pens here. I'm going to divide both sides by pi and 15. And when I do that, what happens over here is those cancel, and I'm left with just z squared. And what happens over here is I'm going to get a number. So let's go get that number. So 1696.5. So 1696.5, and I'm going to divide that by pi times 15. I'm using parentheses in the calculator so it knows to divide by that whole amount, both pi and 15. And I get this really nice result, 36 point bunch of zeros and an 8, which is 36, for our purposes, for where they're asking us to round. And that's equal z squared. You take a square root on both sides, so square root here, square root here. Here you're left with a z, and here you get a 6. And it's meters, so 6 meters. Just for the sake of classes going forward, technically it's not exactly 6 because there's these other decimals. So here again, what I'm going to do is let the calculator do the work. I'm going to hit second square root, then I'm going to hit second answer. So that takes whatever your answer is, even if it's not a nice one, like a 36. And this one actually isn't quite 36, and then finds the square root of it. And it's 6 for where we're rounding, but there are these other numbers out here. So it's important to know your calculator can do that. But for this particular problem, the answer ends up being 6. And that's it. That's how you solve for the missing dimensions.